Now, the reason we want to look at the origin of water here in Iceland is because of some ideas scientists were getting in the 1980s that perhaps comets could have contributed to Earth's water. We think now that probably the Earth formed out of building blocks that were relatively dry, yet we see this magnificent ocean, which actually is a very small amount of water on Earth, and the question is, where did it come from? Now, if Earth formed dry, some people thought in the 1980s that perhaps the icy leftovers of our solar system's formation, which are comets, could have supplied that water when they smacked into Earth early in Earth's history. And the one way to test this theory was to look at the chemical composition of water in comets and compare it to the water we have on Earth. Namely, what we're looking at is the heavy form of water. Water's form is H2O, two hydrogens and an oxygen, and sometimes the hydrogen can have a heavier form called deuterium. So we were going to look at how much heavy water versus normal drinking water we had on Earth compared to comets. Well, unfortunately, it didn't quite match. Comets' water is a little bit heavier than what we have in the oceans, and it occurred to us that maybe ocean water doesn't well represent what Earth got in its earliest history. And so that's where the geology comes in. Turns out that mantle material, rocks and magma that come up from great depths may actually preserve a fingerprint of Earth's earliest or primordial water. And what we hope to do in Iceland, in particular at these young regions where we have the freshest rocks that have come up, the youngest rocks, is to capture tiny little minerals that may have frozen in a signature of this early Earth water. And we want these young lavas so that the minerals aren't too badly eroded and degraded.